Hello, welcome to lesson 7.2 on transformations. So this video is designed for Math 1315, College Algebra, and there are a lot of resources in Canvas from our textbook, but the reality is a lot of those are quite different from what I would have handed out during class. So I am making my own video here for anybody who, for whatever reason, didn't get the in-class version of this whole lesson. It's an important one. It's not just this one section where we need to know this information, but we'll be using it in other lessons as well in the future of the course. So it's really important to get off to a good start with this topic. I've made a quick list of what are the things I'm going to be referring to during the video, starting with the whiteboard, which is what you're looking at now. I'm going to show a different screen of it. That's going to have a summary of all the different types of transformations we're going to see in this section. We'll also be referring to the PowerPoint notes. If you're watching this as an in-person student, you would have gotten these handed to you, probably stapled with 7.1 notes. So maybe flip a few pages in to find them. There's another packet you may have received, classwork 7.1, 7.2. That's what it sounds like. It's classwork, it's in-class examples. And I want to look at least a couple of those to practice graphing these graphs by hand and what you'll be expected to do for that. And then finally, we'll also take a look at homework 7.2 examples. So you also are comfortable with graphing online using the computer, because that's different from graphing by hand, and probably a little easier as well. All right, so here is the whiteboard that I was referring to. This is kind of a summary of the different types of transformations we're going to see. I haven't named them yet. I haven't said what they are, but I just wanted to show you the list right away. Basically, transformations, the word transform means to change, right? So you're changing functions in different ways. And so this is going to be a very visual lesson where you'll watch or you'll see graphs changing in different ways. They'll shift right and left, up and down, they'll flip, they'll get stretched, they'll get compressed. Those are kind of the main categories here. So before we fill these in, I do want to take us to the PowerPoint notes. And so I'm not going to give away what all this is. We're going to come back to this screen multiple times and then kind of add to it as we go. So imagine this is like a whiteboard on the side of the classroom, or maybe on the left side, and we'll be kind of adding to it throughout the lesson. All right, well, let's get to the PowerPoint. We start off this section with what's called a library of functions, or just kind of a visual list of common functions. It's just good to get familiar with these. So I'll just quickly name them, starting with the top left, sort of a horizontal line. F of x equals c. This is sometimes called a constant function. So I'm just writing the word constant. It's a horizontal line, just be able to recognize that. The next one, f of x equals x. As you can see, it's a line going through the origin with a slope of 1. It's a line, it's linear. Sometimes we also call this the identity function, because all of the coordinates are equal to each other. They're identical. So you'll see the point 0, 0, 1, 1, 2, 2. So basically y equals x for the whole function. The ones we'll really be using a lot are actually the next two. So this V-shaped graph, you can see it's f of x equals absolute value of x. That's a good thing to start. Sorry, I'm spelling and talking at the same time. Absolute value. It's a good one to start recognizing. The V-shaped graph is an absolute value function. Then the one on the bottom left of the page or of the slide, f of x equals x squared. This is called a parabola. A word that we use to describe this type of function is quadratic. The quad you might think of as meaning 4, but it actually has to do with something being squared. So x squared is a quadratic function. So when you see functions that have parentheses squared, that will also be some kind of a quadratic function. The next two, you'll see them here and there, not as much in this class anyway, but you will sometimes see them. F of x equals square root of x. I'm just going to call that a square root function. Nothing fancy there to say about that one. I will point out that it's kind of a sideways parabola. So if you can imagine this quadratic function being sort of tipped on its side, it's only the top half of it. Later in the course, we'll learn about inverse functions, and that's kind of what these are. X squared and square root of x are inverses of each other. But for now, just kind of recognize the visual shape of what that graph looks like. It's kind of a curve that sort of looks like it's flattening out eventually. Yeah, so there's the square root function. And then the last one that we see on here is called a cubic function. F of x equals x cubed, or x to the third. There's so many more functions. This is just a few of them, some ones that you want to start to recognize and get comfortable with and get familiar with. But the two main ones that you'll want to really get comfortable with are absolute value, the V shape, and then the quadratic function, which looks like a parabola or a U shape. All right, let's move to the next slide. Maybe. Sorry. I have temporarily forgotten how to change slides. All right, hang on. I'm going to pause my video for a second. Pause. All right, we have shifted to the next slide. So types of transformations. We're going to learn about these different categories or different types of transformations. And here's where we'll go back and forth filling in what was on that whiteboard screen. The first type is shifting, vertical shifts and horizontal shifts. So when you're shifting a graph, you're not changing the shape of it. The shape is staying the same, it's just moving. So it's not becoming bigger or smaller or longer or wider or anything like that. It's just moving. So the one on the top left here, f of x or y equals f of x plus c. This would be the graph of y equals f of x shifted c units vertically upward. So here's your first one to recognize, f of x plus c, that shifts the graph up c units. And then f of x minus c would be shifting down c units. So those are two types of shifts called vertical shifts. Okay, so what you're seeing on the graph here in blue is that original absolute value function. We just saw it on the previous slide. And then in red is g of x equals absolute value of x plus 3. So that plus 3 has moved this graph up 3 units. All right, so that's an example of a vertical shift. Over on the right side here, we have two more types of transformations, horizontal shifts going side to side, f parentheses x plus c. So f of x plus c. That's different from f of x plus c. It sounds the same when we say it, but visually it is not the same. So when that plus c is inside parentheses, that's not an upward shift, that's actually a left shift. You might have expected it to be to the right, but it's actually to the left. So f of x plus c shifts your graph to the left c units. And then f of x minus c shifts your graph to the right. So down below, visually what we're looking at is on the left here, y equals parentheses x plus 2 squared. That graph has been shifted 2 to the left. So instead of having its vertex, its center point at the origin, which is where that parent function, that original function would have been, it's been shifted 2 units to the left. Similarly for the other one, y equals parentheses x minus 4 squared, that's been shifted 4 units to the right. So it's over on 4, 0 rather than 0, 0. All right, so you've gotten your first big category of transformations now. Technically, there's 4 different types we've seen so far, up, down, left, and right. Let's go start filling in our whiteboard, our kind of summary list that we were looking at the beginning. Okay, and it looks like I have put these a little bit out of order, but that's okay. So the ones at the top, actually, f parentheses x plus c, and f parentheses x minus c, those are actually horizontal transformations. We are shifting horizontally. So the x plus c, that's going to be shifting to the left. And here that arrow is confusing, sorry. Whoop. And then f of x minus c, that is going to have our graph shift to the right. All right, so notice the plus c and the minus c are happening inside the parentheses. something I've written off to the side here just to kind of help us memorize these things. Anything happening inside the function, inside the parentheses, that's going to be some kind of a horizontal transformation. So just kind of keep that in mind as we learn about some other ones. Then next we had f of x plus c and then f of x minus c. Those are the vertical translations or vertical transformations. The plus c is when we shift up. And then the minus c is when we shift our graph down. All right, so that's all we've seen so far. We'll kind of put that in its own little section there. I would say more than half of your work that you'll be doing with transformations will involve those types, left, right, up, and down. But we do need to see some more types of transformations. The next types will involve reflections, and then we'll get into the hardest types, stretching and shrinking. So we'll go back to our notes now. All right. So let's talk about reflections. So a graph is reflected when there is a minus sign somewhere in the function. So the first type, when you have the graph of y equals negative f of x, this is called a reflection about the x-axis, or a reflection across the x-axis or over the x-axis. The word about might not be that comfortable, but that's okay. The word I would use probably is just upside down. So it's sort of an upside down look to the graph. So when you have a negative sign in front of your function, essentially all of the y coordinates have been multiplied by -1. So your new graph is now upside down. It's an upside down version of the original function. So negative f of x reflects over the x-axis. Again, you might just write upside down. Another phrase you might write is, this is a vertical reflection from up to down, or vice versa. Meanwhile, if you have f of negative x, if that negative is inside the parentheses, that's going to be a horizontal reflection, side to side. So horizontal reflection. We don't see this type very often. So most of the time when you see a reflection, it's actually going to be the first type that we just saw, up and down. So a vertical reflection over the x-axis. That is much more common. However, we will sometimes see this other type where you're reflecting side to side. So our original graph was y equals square root of x. And then our new graph got reflected across the y-axis. And now it's sort of heading to the left instead of heading to the right. So this dashed line is the reflected graph. All right, let's add those to our list that we had on the whiteboard. Okay, so the next types were reflections. So negative f of x, see that negative sign on the outside? That's a vertical reflection. Okay, technically it's over the x-axis, or it's the upside down one. That's this type. And then if you have f of negative x, see how that negative is now inside the parentheses, that's going to be your horizontal reflection. And technically that's over the y-axis. All right, there we go. All right, so we have all of our shifting left and right, up and down. We did those. We've just seen some reflections. You can go vertical over the x-axis. You can go horizontal, sideways over the y-axis. These last two types are called stretching and shrinking. These last two types that we'll see will change the shape of the graph. So sometimes these next two types are called non-rigid transformations because the graph does not stay the same shape. It changes its shape. All right, so we'll start with vertical stretching and shrinking. So when you have that c, or that whatever the number is, c times f of x, when you have that c on the outside, that's going to be a vertical stretch or a vertical shrink, depending on the value of c. So if c is greater than 1, it's going to be a stretch, kind of looks like the graph is becoming taller and narrower. If we were in person, I'd be making this motion like I'm stretching out Play-Doh or pizza dough or something, like a long piece of string up and down. The graph is being stretched. It's like all the y coordinates are getting multiplied by a certain number. So down below, this green graph is a stretch of the original blue graph. So y equals x squared is the original. Y equals 4x squared. Okay, now all those y coordinates got multiplied by 4. The graph is 4 times as steep. It's going up 4 times as fast as it was before. So that's a stretch by a factor of 4. But if you have a fraction, so if your c value is less than 1, so if it's between 0 and 1, in other words, a fraction, now you're shrinking the graph. Now you're multiplying the y coordinates by maybe 1/4 or 2/3 or 1/2. If you have half as much as something, or if something is 1/4 the height it was originally, it's shorter, it's compressed, it's shrunk. So it sometimes kind of looks like the graph is being flattened. That's what this red graph looks like. You might at first just think it looks wider, which it does, that's true, but the important part right now is that it's vertically shrunk or vertically compressed. It sort of has a flatter look to it. It's going up at a much slower pace. All right, moving over to the horizontal stretching and shrinking. These are probably the least common type of transformation that you will see. In fact, it's very likely you won't see any of these on the homework, but you could, and especially if you ever take trigonometry, that's what you're looking at down below here, by the way, this kind of wavy graph. It's called a cosine graph. There's also sine. That's another type of trigonometry function. We're not doing that in this class, but they look like waves. So this red wave here is the original g of x equals cosine of x. The blue graph is cosine of 2/3 x. So the graph has actually been horizontally stretched in this case. So the rules we just talked about with vertical stretching and shrinking, it's actually the opposite for horizontal, which is confusing. So if you have f of x equals c times x, if c is a big number, more than 1, that weirdly shrinks the graph horizontally. And if your value of c is a fraction, like we have down below here, the cosine of 2/3 x, that's actually going to lead to your graph being horizontally stretched. So it's all backwards from what you might think. For the time being, if this is the first time you're ever learning about any of this, give yourself a pass on the horizontal stretching and shrinking. It'll come to you eventually. You'll kind of like fit it in with all of your patterns that you're learning. But for now, it's kind of information overload. So don't worry about the stretching and shrinking too much. You'll need it a little bit, especially for the vertical stretching and shrinking. The horizontal, not as much right now. All right, let's finish filling in our whiteboard. So we have our complete list of transformations. Okay, so what we just learned is when you have c times f of x, that's going to be a vertical stretch or a shrink, depending on how big c is, right? So remember, if c is greater than 1, that's going to be a stretch. If c is less than 1 or between 0 and 1, that's going to be a shrink. So that kind of makes sense. That's logical, right? Usually the vertical transformations seem to make some good sense, right? Like plus c was up, minus was down. Seems reasonable. But then with horizontal, it's all backwards, right? So remember how the horizontal shift plus was to the left and minus was to the right? That's backwards from what you might expect. Same thing here. When you have f of a number times x or f of c times x, that's going to be a horizontal, I'm going to say shrink or stretch. I'm saying it in the opposite order as before to remind us that the rules are backwards. Oh, and I misspelled stretch. Excuse me for that. All right, you get the idea. Let's fix that. Horizontal shrink or stretch. Okay, so if c is greater than 1, it's a shrink. Yes, that is correct. It's backwards from what you would think. And then if c is a fraction, it's actually a stretch. So there you go. So that's the summary right here. theoretically now you know everything you need to go do the homework and do every graph problem you'll ever see. Of course, we know that's not necessarily true, but that's the summary. Let's go back yet again to the PowerPoint. We're going to practice making a graph by hand, and it's going to be a sketch. So here's sort of the general procedure for graphing if you have a lot of transformations or a sequence of transformations. So you can see there are these 5 steps. I would say you can kind of boil it down to really 2 main steps. Just make sure if there's a horizontal shift, start with that. So left or right, make sure you take care of that first. And then do your vertical shift last. So end with your vertical shift up and down. A lot of times it doesn't matter. But if there is any reflecting that you're going to do that first before you shift up and down. If you mix those up, you could end up with problems like this blue graph here. If we reflected it upside down and then we shifted it up or down, that would be different from if we shifted it up or down and then reflected it. Anyway, just take my word for it. The order will sometimes matter. So try to follow this to get your graph to look how it should. All right, so we're going to do this by hand, just a sketch. I don't even have graph paper fully lined, right? It's just kind of a lot of blank space. So we'll do our best here. What we have graphed in blue is f of x equals x squared. We're going to graph g of x equals negative parentheses x plus 1 squared minus 2. So what we should probably do is just know what all the transformations are that are kind of built into this equation. I would suggest kind of working from the inside out. That kind of follows our order here. So we'll say go from the inside out. Meaning observe what's happening inside the parentheses first. See how that's x plus 1 in parentheses? That kind of matches the f of x plus c. Remember that? That's going to be a shift to the left. So we're going to start by shifting our parabola to the left 1 unit. Then the next thing we can look at is noticing that there's this minus sign outside the parentheses. That's like minus f of x. So that means we're going to reflect our graph upside down. It's going to be a vertical reflection over the x-axis. So our graph will then look like this upside down parabola shape. Finally, the last thing is going to be that vertical shift. That minus 2, it's kind of like f of x minus c. We're going to go down. So that's why the last step will be to go down 2 because of this minus 2. So that's the general plan. I'm about to erase and kind of clear all the writing off my screen for now, so feel free to pause if you need to, and then we'll work through making our graph. All right, so we have our original function already there, f of x equals x squared. So now let's work on shifting to the left 1. Now I'm going to pick a couple points on this graph that we can focus on. So let's notice that the vertex of this graph is 0, 0. So let's move that vertex to the left 1. So instead of 0, 0, it's going to be at negative 1, 0. We'll just move it 1 unit over. Let's do the same thing with a couple other points. So how about this one, 1, 1, maybe 2, 4. We can move those all to the left. So 1, 1 will now be at 0, 1. 2, 4 will now be at 1, 4. All right. So when I have those points shifted to the left, here's what I would have. You might not want to do this full sketch yet, but what I've very roughly just tried to draw here with a dashed line is that's what my graph would look like if all we were doing was shifting 1 unit to the left. We picked a few points on the original function, move them to the left. But that's not all we're going to do. We have some other things to do as well. So let's work on reflecting over the x-axis. We'll start with that negative 1, 0. It's directly on the x-axis, so I'm just going to leave it there. Now, this other point that we had, 0, 1, let's reflect that over the x-axis. So basically, however many numbers above the x-axis we were, let's do that same amount below the x-axis. So see how we're 1 unit above? We're going to move it to 1 unit below. And then what was the other point? Let's see, 1, 4. Okay, so instead of 1, 4, we're going to go all the way down to 1, negative 4. Okay, so again, this isn't my final graph, but here's my sketch. I'm doing this in purple now. What it looks like now is this sort of upside down parabola that's centered at negative 1, 0. So it's moved to the left so far, and we reflect it over the x-axis. Our last transformation is going to be the vertical shift. So next we're going to go down 2. So let's take those points we just plotted and just subtract 2 from their y coordinates, or just move them down 2. So this negative 1, 0 is now going to go down 2. So now it's at negative 1, negative 2. Let's see. What else did we have? 0, negative 1. We'll move that down to 1, 2. That'll be at 0, negative 3. This point, 1, negative 4, I'm out of space. Hopefully you have a little space on your paper. I'd have to go down to 1, negative 6. All right. So there you go. I mean, it's a little messy. It's not perfectly accurate, but we have a lot of the basics. We know the correct shape of our graph is, since it's a quadratic function, it's a parabola. We have shifted it 1 to the left. We've reflected it over the x-axis and made it kind of upside down, and then we shifted it down 2. All right. So I think what's left on the PowerPoint is some examples I took from the homework. So I just kind of put screenshots into your PowerPoint so you could view those. I think what will be most useful is to just go show you the actual homework. Okay. But we'll kind of, what you'll notice is you'll see similar problems with different numbers. So what you see next is homework example 7.2, number 1, y equals x minus 4 in parentheses squared. The actual number 1 that I go find right now might be a different number. Instead of x minus 4, it might be x minus 5 or 2 or something, but the same general idea will be there. So we'll look at number 1, we'll look at number 2, and 12. That's the plan. So I'm going to pause the video and change the screen. And when we come back, we'll be looking at the homework so you can get a sense of what you'll be doing actually online with graphing. All right, so we are now looking at homework 7.2, question 1. So on your notes, your equation is y equals parentheses x minus 4 squared. Mine is y equals parentheses x minus 11 squared. So it just kind of randomly generates. So whatever the number is, it'll be x minus something. So we need to fill in the blank here and figure out what kind of transformation are we going to be doing here. If you recall from our whiteboard, I'll quickly go back and remind us what that was. It's this second transformation that we listed here, f parentheses x minus c. That was a shift to the right. So if there's a minus a number inside the parentheses, that's going to be a horizontal transformation to the right. All right, so that's going to help us. So we know we're going to be moving to the right 4 units, or for me, it's 11 units. We're going to be shifting 11 units to the right. But what we're going to be starting with is something. What are we going to start with? Well, notice how it's parentheses squared. We're going to start with y equals x squared. That's the original function we'll start with. It's going to be that parabola centered at the origin. So I'm going to type in x squared in the fill in the blank, check my answer. All right. And then we get to make the graph. Okay, so here we go. Graphing by hand would be different. It would take a lot longer. Thankfully, we don't need to do that. Here's what you do. Just click on the graph anywhere. It doesn't even matter where. Now I need to choose the right type of graph that we're going to make. It's not a line. It's not the absolute value. It's not that V shape. It's also not this x cubed kind of squiggly line. We know it's the parabola. It's called the x squared tool. So when I hover my mouse over it, I see this little x squared tool message come up. So that's what I'm going to click on. Now, we are going to be graphing parabolas other times in the course, and sometimes we'll need to be a little more accurate. But for now, you get to just click anywhere on the graph and magically a perfect yellow parabola will appear. So that's y equals x squared. It's already graphed for us. I didn't do anything other than just click anywhere, and it's already centered at 0, 0. What we need to now do is transform the function. We need to move it somehow or shift it or whatever's going to happen. And now we decided we are shifting to the right. So I need to go to this horizontal shift, kind of sliding bar, I guess, down in the bottom right corner of this gray box that just appeared. For me, I'm shifting 11 units to the right. So I'm going to click on the gray box. You see a little number appear, 0.00. I want to move it until that number turns to 11. And you might notice the yellow graph, that parabola, is moving as I am moving my little box. Okay, so I just shifted the graph 11 units to the right. I just clicked on horizontal shift and dragged the gray box 11 to the right. And then I let go of the mouse and there it is. Check answer. Okay, and as you may have noticed in that toolbar, there were little places where you could select reflect over x-axis, reflect over y-axis, vertical shift, other things you could do. You can drag it up and down sometimes, you'll reflect it, etc. So that's number one. That's an example of a horizontal shift to the right. My plan is to show number 2 and then number 12, which is the last question. So number 2, different setup. There's some little multiple choice questions that we have to answer, and then our graph will be multiple choice as well. All right. On your notes, the numbers are different, but the general style of the question will still be the same. So mine says g of x equals 1/2 absolute value of x minus 1. So we need to describe how the graph of that function can be obtained from the basic graph. So if we start with f of x equals absolute value of x, how are we going to shift it and transform it into 1/2 absolute value x minus 1? All right, so the 1/2 is going to do something, and then the minus 1 is going to do something. The 1/2 absolute value x, that's going to be a vertical something. Let's see. It's outside the function, so I know it's something vertical. Do we remember what this is? This is the one where you had c on the outside. So it's either a stretch or a shrink. This is going to be a shrink because that fraction is between 0 and 1. So it's a vertical shrink. All right, now that minus 1, that's going to be a vertical shift down 1. Okay, so I'm kind of making all these notes first before we even read the full question. I think this is a good approach. Kind of gather all your information, make sure you list everything you know, and then see how you can answer the question. All right, so here we go. It says start with the graph of, okay, they have h of x, same thing. H of x equals absolute value x, then something. Okay, my drop-down menu says shrink or stretch. We decided shrink. So we're shrinking it vertically by a factor of, now I get to type in a number, 1/2. That's that number on the outside. Yours might be 1/4 or something else. Finally, shift it down 1 unit. Okay, I need to clear some of my writing here so we can see it. But yeah, I'm going to choose the choice that's going to be down 1. So up 1/2, no. Down 1, up 1, down 1/2. Yeah, it's down 1. Okay. So that's the fill in the blank and drop down menu type questions. Now we need to choose the correct graph. Okay, so we just described it. Now we choose which one actually matches our description. I mean, you can pretty much narrow it down to the only one that actually has a shift down. So I'm going to do a really rough sketch off to the side here. Here's my original V-shaped function. It's going to go down 1. And I know it's going to be a vertical shrink, so it should kind of look a little flat. So yeah, do your own sketch first before you just stare at all the choices and get confused. But yeah, we know it's going down 1 and we know it's been flattened or shrunk vertically. It's going to be choice D here. That's the only one that's been shifted down with its center below the origin. A is shifted up, So it's not that one. B is shifted up as well and kind of has that shrinking look to it, that flattening. C was shifted to the left. We know it's not that either. So D is the only one that's gone down. So that's the one we choose. Okay, and you know this probably, but yours is not necessarily choice D, but it will be a similar type of question. And look at that, number 3. I think 2 and 3 are pretty much the exact same question with slightly different numbers. So enjoy that practice. All right, we're going to skip ahead to the last problem on the assignment, question 12. This one does not involve a visual graph at all. Oops. It's a multiple choice question about equations. So it says, write an equation for a function that has a graph with the given characteristics. The shape of y equals x squared. So that means it's a parabola. Okay, you do shape graph. But it's upside down. Okay, got it, upside down. Shifted right 2 units and up 5 units. Okay, right 2, that means we're going to have x minus 2 in parentheses. Remember, that's kind of like the f of x minus c, shifting to the right. Up 5, that means we're going to have a plus 5 on the outside of the function. So see, I'm kind of planning ahead. Now we look at our choices. Oh, and I forgot about the upside down part. Okay, the upside down is a reflection. So that means we need a negative sign. We need a negative sign in front of f of x. Now, if we look through our choices here, all of them have y equals negative something squared, and then either a plus 5 or a minus 5. So they all have the negative. So we got the reflection covered. We know in the parentheses, and by the way, since it's a parabola with the x squared equation, we know the parentheses will be squared. But inside the parentheses, because we're shifting to the right 2 units, we know we need to have x minus 2. So it's not choice A that has x plus 2. It's also not choice C. Those both are shifting to the left instead of to the right. Okay, and then if we just focus now on the vertical shifting up 5, we know we need to have a plus 5. So it can't be choice B that has minus 5. That just leaves choice D. Y equals negative parentheses x minus 2 squared plus 5. The minus 2 is shifting to the right, the plus 5 is shifting up, and then the negative sign out front is the reflection. All right, so there you go. So that's 3 out of your 12 questions for 7.2. That might be enough for you, but if you want a little bit more, the next thing I'm going to show is the classwork packet. We would have done this during class. So actually, I would suggest if you're going to take a test in person, which probably you are if you're watching this, you probably do want to try a couple of the graphs in the classwork 7.1, 7.2 packet. So I'm going to pause my video once again and try to show you what that would look like for you to make those graphs by hand. We'll probably just do 1 or 2 of them. All right, so here's the handout that I'd like to use with you. I'm showing the front page right now. It's the classwork packet, classwork 7.1, 7.2. Section 7.1 was all about symmetry. And then we're going to focus on 7.2 right now. So I'm going to scroll down. You'll have to turn some pages. Okay, so the first 2 pages are all about section 7.1. What I want to look at are some graphs starting with, let's see, 21, 22, 23. So just kind of make some comments about those graphs and we'll practice doing at least 1 or 2 by hand. Okay, so for number 21, 22, and 23, it says graph the basic function using a solid line and the transformed function using a dotted line. All right, so I'm thinking let's do at least one that involves absolute value, and then we'll do one that involves x squared or a quadratic function. So let's start with 22. I think that's a good one to do. I'll zoom in a little bit. So number 22, f of x equals absolute value of x minus 4. So there's nothing graphed on here right now. So we need to first be able to graph f of x equals just absolute value of x. That's sort of the basic function that we're talking about. So feel free to just make a little chart, plug some numbers in to get some points. Now we already know approximately what we expect this graph to look like. We know it's a V-shaped graph back from our list of basic functions. But what you can do is just plug in a few numbers for x, maybe a few negatives, 0, and a few positives. So I just made a list, -1, -2, 0, 1, 2. And you know what? I'll switch the order. That's going to bother me. Let's actually go in order. -2, -1, 0, 1, and 2. It doesn't have to be 5 points. It doesn't have to be those 5 points. Generally, I would say if you're lost on what to plug in, start with 0, maybe go positive, and then go negative. You want to get the full shape of your graph. So if you only do positives, you're going to miss out on this other part of the V shape. All right, so we're taking the absolute value of each of these numbers. Absolute value of 0 is 0. Absolute value of 1 is 1. 2 is 2, etc. Because absolute value just means distance from 0. If the number is already positive, it's positive. So I know the points 0, 0, 1, 1, 2, 2, those are all on the graph. So essentially you can start by plotting those points and then extending your line. Mine's a little off here. It should have a positive slope, a slope of +1 actually, to be more accurate. And here, I'm going to edit it a little bit. But yeah, you're doing it by hand. You might not have a straight edge, so just kind of do your best there. And then when I plug in my negatives, absolute value of -2 is +2. Absolute value of -1 is +1, etc. So you start to see, oh, now the graph is going up in this other way. So on this other half of the graph, you have this slope of -1. So all of that was the original function. That's just the basic function of absolute value of x. What we now want to do is graph the new function. We need to graph absolute value of x minus 4. So when you have the x minus 4, we know that means we're shifting 4 units horizontally to the right. Okay, so this is really like f of x minus 4. That's kind of what's going on there, right? The -4 in the parentheses is a horizontal shift to the right. So let's take our points that we just plotted and just start moving them to the right. I'm going to start with that center point 0, 0 and move it 4 to the right. 1, 2, 3, 4. All right, and then 1, 1, we'll move that to the right. 1, 2, 3, 4. Yeah, once you do it to a few, oops, these straight lines are not great today. Once you do it to a few points, sorry, a little pop-up in my way, you should kind of have the general shape of the graph ready to go. Oh my goodness, okay. You get the idea. Well, as you can see, it's not always perfect, but we do a sketch. And then of course, I know there's another side to that V shape. There we go. So technically I had my original graph that's in this sort of red and blue here. The green is the new one where I've taken my points and shifted them 4 to the right. So that's what you might have to do by hand, maybe on a test. Let's take a look at number 23 right below it. So I'm shifting down, same page for you. This one is h of x equals x minus 2 in parentheses squared minus 3. Okay, so this time our basic function is going to be f of x equals x squared. This is a parabola. So let's plot some points. I think I'll just use the same set as before, -2, -1, 0, 1, 2. I might want to add 3 and -3 to that list. We'll see. So all we're doing now is squaring them. 0 squared is 0. Start at 0, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So I'm plotting 1, 1, 2, 4, 3, 9. So you can start to see my curvy half of my parabola when we square these negatives. -1 squared is 1, -2 squared is 4, -3 squared is 9. This graph has that y-axis symmetry that we have learned about. This is an even function. So there's my original function. My graphing's a little shaky on my computer screen. That's okay. Do your best. And what we're now going to do is transform this graph. So what are we going to do? Let's see. X minus 2 means we're going 2 to the right. And then this -3 on the outside of the function means we're going 3 down. So this is kind of like the one we did in the PowerPoint notes, I think. So let's do those 2 steps to each of these points. So let's start with that vertex at the origin, 0, 0. We'll move it 2 to the right and then 3 down. 2 to the right and then 1, 2, 3 down. So my vertex is now down at 2, 3. And then we'll carefully do that with some other points as well. Let's go to 1, 1. So we'll move it 2 to the right and then 3 down, 2, 3. Negative 1, 1, 2 down, 1, let's see. Or sorry, 2 right, my mistake. So I'm over here on the left side of the vertex. I'm trying to get this bottom U shape going. The order doesn't matter though, but we just want the general shape of the parabola. So negative 1, 1, I'm going 2 to the right and then 3 down. There we go. Okay, so I should probably do it a few more times with some other points. Let's see, 2, 4, 2 to the right, 1, 2, 3 down. And then we'll do negative 2, 4, 2 to the right, 1, 2, 3 down. There we go. And then we'll do it with the higher points too. 2 to the right, 1, 2, 3 down. 2 to the right, 1, 2, 3 down. Yeah, if you don't include enough points, you might find yourself drawing these like vertical lines on the side of your parabola. So anyway, do your best. As long as you've labeled your points and kind of like plotted them with those little circles like I've done, that's good enough. I think I've done a very solidly medium job on these graphs. And so that's what I can expect of students as well. All right, so I think I'm going to end it here. So that's kind of an overview of transformations. Hopefully you got some good examples on the homework and you've been able to do some graphs by hand. We will revisit this topic in future sections. So this is definitely a good one to really make sure you have a solid understanding of. Please reach out if you have questions and I would be glad to go into more detail or yeah, give you what you need if you need any help. Okay, thanks for watching and that's it for now. Thank you.